This video is on the logarithmic properties. As a little review, we can go from exponential form to logarithmic form. So basically that means something like 2 to the third power equals 8. You're going to rewrite in logarithmic form. The log base 2 of 8 is 3. So we say the log base 2 of 8 is 3. So that's basically how you go from exponential to logarithmic form. In this video, what we're going to do is use the product rule, the quotient rule, the power rule. We're going to expand and condense logarithmic expressions, and at the end, we'll use the change of base formula so that we can go ahead and simplify these. A few things to keep in mind. The log base b of 1 is equal to 0. This should make sense because this means that b to the 0 power equals 1. And as you know, any number raised to the 0 power is equal to 1. So if you're ever asked to find the log base 5 of 1, you know that's 0. The log base 1/3 of 1, that is equal to 0. Because any base raised to 0 is going to always equal 1. And as a reminder, your bases for logarithms and for exponential functions always have to be positive. So here are the examples. Again, the log base 5 of 1 equals 0, since 5 to the 0 power equals 1. Another one that we need to remember is the log base b of b is equal to 1. Why? Because this means b to what power is going to bring me back to the same number. So if I were to write the log base 5 of 5, that's going to equal 1. The log base 7 of 7 equals 1. The log base 1/2 of 1/2 is equal to 1 because any base raised to the 1 power brings me back to the same base. So these are two important properties that we need to keep in mind. Similarly, when you see something like the log base b of b to the x, what does that mean? If I were to rewrite it, this means that b to the x power equals b to the x power. And that is a fact. And so basically what I can do here is that I can just cross out whenever I see the log base b of b, I can cross that out and I know that's just going to equal to x. So if you take a look at an example, like the log of base 5 of 5 to the third power, this is the same thing as just saying 3 because 5 to the third power is going to equal 5 to the third power. Now, you might see this instead as the log base 5 of 125. And then again, either you realize 5 to the third power is 125, or you can go ahead and rewrite this as 5 to the third power and apply the property, and you know that that's going to equal to 3. If you take a look at the log of 100, as a reminder, when you don't have a base, this is called the common logarithmic function. And so the base is 10. So this means 10 to some power x is equal to 100. That means that x in this case is going to equal 2. So one of the things you can do is rewrite the problem as the log base 10 of 10 squared because that's 100. And of course, these basically cancel. So your answer is 2. Okay, so you can apply these properties so that you can go ahead and evaluate them. Another thing that we have to keep in mind is that e, which is the natural base, which is approximately 2.718, the inverse of it is going to be the natural log. Okay, so we're not going to write the log base e of x. Instead, we're going to write the natural log of x. So natural log and e, they cancel each other out. So if you see e raised to the natural log of x, that means this is going to equal to x because e and natural log are inverse functions. E is the natural base, so you're always going to see e raised to a power. If you have e, like in this example right here that I'm circling, to the log base e of 7, again, the log base e is just natural log, so this means e to the natural log of 7. E to the natural log just cancels because they're inverse functions, so the answer is just 7. Similarly, if I have the natural log of e to the 4th power, the natural log and the e are inverse functions, they cancel, so the answer is equal to 4. So besides those 4 properties that we've just gone over, we have to keep in mind that if the log base b of m is equal to the log base b of n. Well, if it's log base b on both sides of the equal sign, that can only be true as long as m is equal to n. And this one seems kind of like common sense, right? But it's going to come into play when we start solving equations based on logarithms. So we can use this one-to-one property to solve equations like the log base 3 of 3x is equal to the log base 3 of 2x plus 5. Because of the fact that it is an equation, and on both sides of the equal sign, I see log base 3, I can go ahead and cancel those out. And that leaves me with 3x has to be 2x plus 5. And now I just solve it algebraically as normal. 3x minus 2x is x is equal to 5. And so that's going to be my answer. Now what we're going to be doing is expanding according to 3 rules. We're going to go through the product rule, the quotient rule, and the power rule. Let's start first with the product rule. If you remember, product means multiplication. So that's important, because what we're doing is basically multiplying these two parts. So if you see the log base b of m times n, you're going to expand. That means you're going to rewrite this with a lot more terms as the log base b of m plus the log base b of n. If we take a look at an example like the log base 2 of 5x, I can go ahead and expand this as the log base 2 of 5 plus the log base 2 of x. Sometimes they're going to ask you to expand things like the log base 2 of 6. And in which case you have to think, how can I possibly simplify this a little bit? Well, let's go ahead and write this as the log base 2 of 3 times 2, which is the log base 2 of 3 plus the log base 2 of 2. And if you remember by the property that we went over, when it's the log base 2 of 2 right here, this is just going to equal 1. So this answer can be reduced or simplified as the log base 2 of 3 plus 1. So there's just different ways of writing the problem that sometimes are helpful when we are solving these. Let's go ahead and try this example. This example is interesting because it is a little bit quite long, so you have to take it a step at a time. Notice here it's the log base 3 of 30x multiplied to 3x plus 4. And I know that basically what I've done is just rewritten the problem, but it's because I want you to see the parts to it. What's being multiplied together, like I said, is 30x together with 3x plus 4. You have to be very careful not to break up that 3x plus 4. So if I had to, I could take the time to expand the number 30. I can go ahead and say, well, 30 is 6 times 5. 6 is 2 times 3. So basically the prime factorization is 2 times 3 times 5. So that's one of the things that I can do. So I'm going to go ahead and rewrite this as the log base 3 of 30x plus the log base 3 of 3x plus 4. What I've done so far is just breaking up the two parts that we are in fact multiplying. Now I'm going to worry about this 30x, and I'm going to use the prime factorization. 2 times 3 times 5 is 30. So I can go ahead and rewrite this first part as the log base 3 of 2 times 3 times 5 times x plus the log base 3 of 3x plus 4. This 3x plus 4 you're done with. You cannot break that up anymore at all because nothing is being multiplied. But here on the left, I can rewrite this as the log base 3 of 2 plus the log base 3 of 3 plus the log base 3 of 5 plus the log base 3 of x plus the log base 3 of 3x plus 4. And this might seem a little extra, you know, like just kind of like a lot of work. Like, why do I really have to expand that 30? And I guess it all depends on the problem that you're working with. So notice again, in this case, I can simplify the log base 3 of 3. That is just going to be 1. So if I wanted to, here I go again, I can rewrite this as the log base 3 of 2 plus 1 plus the log base 3 of 5 plus the log base 3 of x plus the log base 3 of 3x plus 4. And it all depends on what they want you to do so far, because maybe they would have been okay with you just expanding as the log base 3 of 30 plus the log base 3 of x plus the log base 3 of 3x plus 4 without having to do the prime factorization for 30. Okay, so now we have to go to the quotient rule. The quotient rule, if you remember, quotient meaning division. So when we are dividing, and like in this case, the log base b of m divided by n, then this is going to be the opposite of what happens when we multiply. We're going to expand through subtraction. So if I give you an example of the log base, I don't know, the log base 7 of 15 divided by 4, I can go ahead and expand this as the log base 7 of 15 minus the log base 7 of 4, and then I can just figure out that answer. Let's go ahead and take a look at this example. In this particular case, it says expand the log base 2 of 15x times x minus 1 over 3x plus 4 2 minus x. Wow, there's a lot going on in this problem. So one of the things that we have to focus on is this bar right here, like the fraction bar, because that means division, and that's going to tell me that I'm going to have to separate those two parts with subtraction. So I'm going to start by doing that first. I'm going to expand the log base 2 of 15x times x minus 1 minus, because I'm dividing, by the log base 2 of 3x plus 4 times 2 minus x. Okay, so I'm basically going to go ahead and separate those two with subtraction. But of course, we just went through the fact that when you are multiplying, you can expand through addition. So I'm going to go ahead and rewrite this as the log base 2 of 15 plus the log base 2 of x plus the log base 2 of x minus 1. Why? Because everything is being multiplied together. 15 is multiplied to x, is multiplied to x minus 1. X minus 1 is a factor in parentheses, so you have to keep it like that. You're not going to distribute or anything like that. Then I get minus, and now here's where you have to be careful, because this minus is going to have to get distributed to all of this. So here what's being multiplied are these two factors right here. So we're going to expand as minus the log base 2 of 3x plus 4 minus, again, because this minus is going to get distributed, the log base 2 of 2 minus x. And then the only thing I think we have left to do, remember all of these right here that I'm going to circle for you, those are all factors. They're together in parentheses. You cannot separate those at all. So you're done with that part. The only thing, if anything, that we might be able to do is to find the prime factorization of 15 and break that up a little bit more. And in this case, 15 is easy because 15 is simply just 3 times 5. So I can rewrite this as the log base 2 of 3 plus the log base 2 of 5. So that gives me the 15. And then I'm just going to take the time to rewrite the rest of this answer. So it's a super long answer. Just be very careful with the subtraction that you had to distribute to both parts when you expand it. And also be careful not to touch those factors when they are written in parentheses. They're together and they stay together, and that's it. Okay, so we did product rule, quotient rule. Now we're going to do the power rule. So the power rule basically says that I am going to rewrite the power in front of log. So if I have, like here, the log base b of x squared, the power rule is going to tell me to take my power and go ahead and multiply it to the front. So this is equal to 2 times the log base b of x. And then you might be wondering, well, why? Why are we allowed to do that? Well, if we follow along, you know that x squared is basically just x times x. We just learned that when you're multiplying, you can expand through addition. So basically what that means is that I'm going to have the log base b of x plus the log base b of x. And in reality, how many of those do I have? I have 2 of them. So that's how this answer becomes 2 log base b of x. And so basically what you have there on your screen right now, 100 is equal to 10 squared. The square root of 3 is equal to 3 to the 1/2 power. 1 over e, remember e is the natural base, which is approximately 2.718, is equal to e to the -1. These are just reminders on how to use these powers, because you can't apply the power rule without a power. So you're going to have to take numbers like 100, that's a perfect square, 36, 25, all of those that are perfect squares, you can go ahead and rewrite them so that you see a power. Anything that has a radical, like the cube root of 5, this means 5 to the 1/3 power. 1 over 10 is equal to 10 to the -1 power. So those are all very important rules for you to review and practice. Let's take a look at the general example here, which tells us exactly what I showed you before. When you have a power, that power is going to move to the front of log. So here we have example number 3. In example number 3, it says to expand the log base 2 of x to the 5th power. So you're going to take the power, which is the 5, and you're going to move it to the front. So this is simply equal to 5 times the log base 2 of x. The power rule is very easy. All right, let's go ahead and try another example. In this case, it says rewrite an expression as a power before using the power rule. This is what I was trying to explain to you before. We have the log base 3 of 25. This can be rewritten as the log base 3 of 5 squared. And then according to the power rule, I can just move the 2 to the front. So this is equal to 2 times the log base 3 of 5. So how do we rewrite 4 natural log of x using the power rule for logs as a single logarithm with a leading coefficient of 1? In other words, how do we go backwards? Okay, how do we go backwards? Well, right now, if we have 4 natural log of x, a number in the front of log or natural log is the exponent. So that tells me this is in fact the exponent. So you're just going backwards and you're going to apply the power rule in reverse. So this is the same as saying the natural log of x to the 4th power. So it's actually quite simple. And you know that everything in math is going forward and back. So just how we learn to expand, we need to learn to condense and bring everything back. Notice this example, which I'm going to rewrite for you. The log base b of 6x over y. If I have to expand this, it's going to be the log base b of 6x minus the log base b of y. The first thing you want to do is take care of the quotient rule, because that's going to make your life a little bit easier. The second thing is look for product rule. So in this case, I have the log base b of 6 plus the log base b of x minus the log base b of y. And in most cases, that's all the work that you have to do. You might have to do the prime factorization of 6, which is 2 and 3, but it all depends on how far they want you to take the problem. For now, this is usually the acceptable answer. Again, this is just a reminder that if you have the log base b of a divided by c, you're going to rewrite this as the log base b of a minus the log base b of c. Example 6 says expanding logarithms using product quotient and power rules. Rewrite natural log x to the 4th times y over 7 as a sum or difference of logs. First thing we want to apply is going to be the quotient rule. If you see that you are dividing, apply the quotient rule first. So that means I'm going to rewrite this as the natural log of x to the 4th y minus, because here's my division, the natural log of 7. So that's the very first thing I want to take care of. The second thing I'm going to take care of is the product rule. So in this case, in the first part, I have the natural log of x to the 4th plus the natural log of y minus the natural log of 7. And then the last thing that I'm going to do is apply the power rule. So this is the order in which you want to do these problems. There's only one power, which is the 4. So I'm going to take the 4 and I'm going to move it to the front. So my final answer is 4 times the natural log of x plus the natural log of y minus the natural log of 7. Example number 7. Use the power rule for logarithms to simplify the logarithm of a radical expression. Notice we want to expand the log of the square root of x, but we can rewrite the square root of x so that it is x to the 1/2 power. That's something that you have to keep in mind. The square root of x is x to the 1/2 power. So then I'm going to go ahead and apply the only rule that I can here, which is the power rule, and I'm going to put that to the front. So I'm going to get 1/2 log of x, and that is my final answer. Okay, from something that easy to something this complicated. If you think about it, first is the quotient rule. Take the time right now to first apply the quotient rule. So that means that this is going to equal the log base 6 of 64x to the third times 4x plus 1 minus the log base 6 of 2x minus 1. So the very first thing is always go for the quotient rule first. It's very helpful, actually. It's going to help you out. Then the next thing I'm going to do is worry about the product rule. In the back, right here, there's nothing else you are going to do there to expand this problem because the 2x minus 1 is a factor. It is together. You cannot break that up. But in the front, I have 64 times x to the third times 4x plus 1. So there's 3 of them there that I can go ahead and expand with the product rule. So I'm going to rewrite this as the log base 6 of 64 plus the log base 6 of x to the third plus the log base 6 of 4x plus 1 minus the log base 6 of 2x minus 1. So we applied the quotient rule. We went ahead and we applied the product rule. And then now I'm going to go ahead and apply the power rule. And one of the things that I can do is I know that 64 is the same as 2 to the 6th power. And that is because 64 is 8 times 8. 8 is 2 to the 3rd power. 8 is 2 to the 3rd power. So 64 is just 2 to the 6th power. So I can go ahead and I can rewrite that as the log base 6 of 2 to the 6th power plus, of course, this one already has a power. I can already tell that I'm going to have to apply the power rule in 2 situations. Remember that these we don't touch anymore because these factors are together and we do not touch them at all. We just let them be. So then now I can apply the power rule. I move the 6 to the front and I will move the 3 to the front. So my final answer is going to be 6 times the log base 6 of 2 plus 3 times the log base 6 of x plus the log base 6 of 4x plus 1 minus the log base 6 of 2x minus 1. And that's my final answer. Hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.